So for this given welded bracket shown, we're asked to design for the required size of the weld needed to resist the given eccentric factored load of 40 kilonewtons. Okay, using electrode 60 for this connection. Okay, so again, yung required, yung tinatanong ng problem is yung size of weld, which is the W. Okay. So as you can see, the connection consists of two lengths of welds. So let us identify these welds by considering a unit length, 1 millimeter at the ends of each of its length. So yung upper horizontal weld, so let me take 1 mm on the left point. Then call me it as point A. Then yung sa kanan, call it as say point B. Then yung lower horizontal weld, yung left end, call it C. And the right end, call it as point D. Okay, so the first step is to locate the centroid. As you can see, the two lengths of welds are not of the same length. So if you will consider the centroid would be somewhere here. Okay, so let us assume that would be the location of a centroid. So you could choose any reference point. No? So let me choose this point C to be my reference point in applying Varignin's theorem. So again, the first step is to locate centroid. Okay, so in locating that centroid, so that would be, this would be our X bar, and this would be our Y bar. And okay, so say length total X bar is equal to the summation of its individual length times X. Okay, so the total length is 100 plus 150. So that is the total length of the two welds is 250. Okay, times X bar is equal to the individual length. Okay, for the first length AB, the length is 100. And the local centroid of AB is here. Sa gitna ng AB. And the horizontal distance of that local centroid of AB from the reference axis would be 50 plus kalahati na 100, another 50. So therefore, the X of it would be 100. Plus for the second length is 150. And the local centroid of CD is here. Kung 150 yan, kalahati na 150, 75. And that would be the distance of the local centroid of CD from the set reference point. So 75. Okay, so from there we could solve for X bar. So that's 85 X bar millimeters. While for Y bar, length total Y bar is equal to the summation of its length times Y. Again, the total length is 250 times Y bar. Then the first length is 100. And the vertical distance of its local centroid from the reference, ulitin ko, the vertical distance of the local centroid of AB, which is here, from the set reference, vertical distance is 100. Plus, for the second length, the length of which is 150, and the vertical distance of the local centroid of CD here from the reference is 0. Vertical distance. So from there, we could have Y bar. 100 times 100 divided by 250. So we got 40. Okay, so that is Y bar. Okay. So after locating the centroid, Let us, since we're asked to design for the size needed, so para mas mabilis, we have to identify na lang kung sino si most stressed. Sino ang most stress point among the 4 points that we have considered dun sa mga length ng weld. Okay, based from the first criteria, diba, ang basihan natin is siya yung pinaka-nearest from the line of action of the load. So the load applied is 40 kilonewton and its line of action is vertical here. And the nearest point or points from that line of actions are B and D. Points B and D. How about for the second criteria, which is farthest from the centroid? Among A, B, C, and D, sino pinakamalayo? Okay, so based from the calculated centroid location, X bar natin daw is 85. So 85 daw to. Tapos yung wide bar natin ay 40. So 40 to. So kung 40 to, so yung taas would be 60. Okay, kung 85 to, di bali ito ay 150, so 1565. Tama ba? Okay, so 65 yung distance. So between C and D, mas malayo si C. No? Between C and D, mas malayo si C. Pero, okay. Tapos kung 65 to, this would be, so di bali ito 65. Kung 100 yan, 35 to. From A. Tama? Okay. So between A and B naman, mas malayo si B. The question is, sino mas malayo? Si B or si C? Okay, so we could calculate naman the actual distance, di ba? The actual distance of B is Pythagorean theorem, yung hypotenuse lang ng triangle. So square root of 65 square plus 60 square. Okay, so ang distance ng B ay 88. Okay, distance ng B from the centroid is 88.459. So check natin. What about the distance ng C from the centroid? Para makuha natin yung actual. Okay, so the distance of point C from the centroid naman ay square root of 85 square plus 40 square. So the distance is 93. So ito yung mga bagay na medyo hindi natin makikita by inspection. So we need to calculate talaga para malaman natin kung sino talaga yung mas malayo. 93.94 yung distance. So ibig sabihin, si letter C yung pinakamalayo among A, B, C, D. Nakuha ba yun? Okay? Now, if you look at the most stress, based from first criteria, B and D, second criteria, it's C. So as you can see, walang common. Walang common na point. Okay. So, paano gagawin natin? So, one is we could solve for the shear forces on these three, B, D, tsaka C. Then, compare mo kung sino yung pinakamalaking shear force. Yun na yung pinaka-most stress. Pero, we could still eliminate one between B and D. Kasi from points B and D, parehas sila in terms of nearest from the line of action. Hindi ba? Nearest from the line of action. Parehas si B tsaka D. So, i-break natin yung tie between B and D considering the second criteria or criterion. Okay, between B and D, sino yung mas malayo from the centroid? Between B and D, sino yung mas malayo from the centroid? Hindi ba yung B? Kasi 60 yung distance sa taas, 40 lang yung sa baba. Mas malayo si B kaysa kay D. So, between B and D, mas malayo si B. So, mas stress si B kaysa kay D. So, we could eliminate na si D. So, from there on, dalawa na lang yung isa-solve natin. It's B and C na lang yung pagpipilian natin to be the most stressed. Question about that thing, that point? Okay. Okay, so let us continue. So we will be focusing our calculation of the shear stress or the shear force between points B and C. Okay, so first is due to direct load. Okay, let's say, so here is the weld AB and here is weld CD. I'm sorry. So A. So weld AB, CD. Okay. So due to direct load, okay, so we'll have RD equals the load, which is 40 kilonewtons. Let's make it 40,000 newtons divided by the total length. Okay, the total length is 100 plus 150, so that's 250 millimeters. Okay, so the direct shear would be 40,000 divided by 250. So we got 160. So that is 160 Newton per millimeter length of weld. And that would be upward kasi yung load na 40 is downward. Okay, plus what about the effect of moment? Okay, so say point A, point B. Okay, so this is D. So here is the centroid. Okay, so let's take a look of point B muna. Okay, so for point B, you draw a straight line at point B from the centroid. Okay. At first, what would be the direction of the moment pala? If this is the centroid, ito yung load, downward, so the direction of the moment is clockwise. So yan yung moment T. Okay, so solve natin muna yung moment T. Moment T is equal to 40. Okay, 40. Say 40,000 newtons times the distance. So what's the distance? So here is the distance, E. Okay, how much is the eccentricity? So that would be 250 minus X bar. Okay, so yan yung magnitude ng moment din natin. Times 250 minus 85. Pag kami mali ako, please let me know. So that is 6600 times 10 to the 3. And the unit of which is Newton millimeter. Okay, and that is clockwise. Okay. Diretso na natin, ano muna yung J, yung polar moment of inertia niya. Okay, its J is summation of its length times L square over 12 plus X square plus Y square. Okay. For the first length of weld AB, its length is 100 times 100 square over 12 plus, ano yung X niya? X is the horizontal distance of its local centroid from the global centroid. And that would be 85 minus 100. Absolute value. So 15. So 15 square plus the vertical distance of local centroid of AB here from the global centroid here, and 60 is 60. So ito yung pinaka J para sa first length of weld. Plus for the second length, its length is 150. Again, length 150 square over 12 what is its x? X is the horizontal distance of the local centroid to the global centroid. And that would be 85 minus 75. And that is 10. Plus, the vertical distance is 40. Okay. So, based from my calculator, ang nakuha kong J is 1,02,083. 0.333. So, shift store ko to sa B. Shift store ko yung moment sa A. Okay. Okay. So balik tayo ngayon doon, no? So let us consider yung point B. So again, from the center of gravity, global, to the point B, I draw a straight line, yung kulay pink na yan. Then I draw a perpendicular line. So ito yung perpendicular line. So ito yung R due to moment T sa point B. Where will be the arrowhead? Kung clockwise yung moment, so pagka hinit niya yung point B, it would be resisting. Therefore, the arrowhead would be upward. Excuse, to the left. Okay? So, di bali magkakaroon tayo ng X component na kaliwa at saka Y component na pataas. Okay? So, yung kaliwa is RTX ng B. Tapos yung pataas is RTY ng B. Okay? Solve natin. So, ano yung RTX component ng B? So, that would be, we have already the moment T. We have already the J. So, we have to multiply it with, kung XB to, we have to multiply it with YB. YB is the vertical distance of point B from the global centroid. And that is 60. Ayan. So, masasolve na natin yung RTXB. So, alpha A divided by alpha B. Okay, shift stores. Times natin ng 60. So, this gives us 395.1767. Let me store it sa D. Okay, so anong unit ng RTXB natin? Newton millimeter square, tapos itong J natin is millimeter square din, no? So that means it's newtons. Tama ba? Ay, sorry. Newton millimeter cube yung J. So, di ba ang lalabas ito is Newton per 1 millimeter length. Okay? And the direction of X component would be to the left. Ayan. Next, how about for RTYB? So, that would be T over J. So, since Y component to, so we need the X distance of point B. And the X distance of point B from the global centroid is 65. Point B. And that would give us alpha C times 65. So we have 428. 108. Shift store ko sa E para walang tapon. And that's again Newton per a unit millimeter length, and that is directed upward. Question up to this point?
None naman po.
Okay, so yun na. So we have solved for all the shear forces. For B pa lang to, no? Okay. Now, sa board exam, pagka lumalabas yung type of question na to sa board exam, usually tatlo ang nagiging tanong niya. Okay, so ano ko na lang din dito ha. Okay, so ganito yung nagiging type of question niya. Halimbawa, unang tanong, what is the shear force R due to direct load alone? Okay, so what would be the shear force due to direct load alone? So if you're asked about that, your answer would be based from the direct shear or direct load alone, and the answer would be 160 newtons. Okay, upward. Okay. What if the question is, what would be the shear force due to moment alone? Okay, so what would be your answer kapag ka due to moment alone? Eh di ang i-consider mo lang, let's say ang tanong is sa point B lang RB. Okay. What would be the shear force at point B due to moment alone? And your answer would be based from the RTX lang tsaka RTY. And your answer would be square root of X component is 395.1767 square plus the Y component which is 428 quantity square. So yan lang yung magiging shear force natin due to moment alone. So kapag kinuha mo yan, so that would be alpha D square plus alpha E square. So that is 582. Your answer must be 582.6158 Newton. And the direction of which is upward to the left. Then finally, if you are asked about naman, what would be the shear force at point B due to eccentric load? Okay. Pagka ang tanong is due to eccentric load, ibig sabihin yan, that would be the combination of the shear force due to direct load plus the moment. So your answer would be, yun na yung pinaka-resultant ng lahat. And that would be summation of forces X, that is yung RTXB, which is 395, 1767 square, plus summation of forces Y. So we have the RTYB, which is 428. Tapos i-plus mo yung RD, yung 160. Quantity square. So yan na yung magiging total resulting shear force due to direct load and due to moment. That means due to the eccentric load. So that would be plus 160. So my answer is 708.54. Let me store it. Shift store sa F. Okay, and the unit is newtons. And the direction of which would be also upward to the left. Question up to this point?
Clear po, sir.
Okay, so yan yung point B. Okay. Pero we're not yet done kasi we have to solve for the shear force at C and compare it. Okay, so i-check natin yung sa C. How about weld at C? Okay, so weld at C. So ito yung point C, no? So draw a straight line from the global centroid. Then draw a perpendicular line. So ito yung RTC. The arrowhead would be downward to the right. Okay? So therefore we have a vertically downward. Tama ba? Vertically downward na Y component, RTYC. Tapos to the right na X component, RTXC. Okay, so let us solve. RTX ng C. X component. So that would be T over J. So naka-shift store na tayo dyan, yung T over J. So i-multiply mo lang to na kung X sub C to, you have to multiply it with the perpendicular distance, and that would be Y of C. Vertical distance ng C from the global centroid. And the vertical distance of C from the centroid is, yun yung Y bar. Diba? So yun yung 40. Y bar 40. So that would be alpha C times 40. So we got 263, 45, 45. Okay, shift store ko sa bagong D. Okay, so that's Newton. And the direction of which is to the right. How about yung RTY ng C? Again, that would be T over J. And the horizontal distance, kasi YC, so we need the X sub C. And the horizontal distance is equal to the X bar. And X bar is, ano nga ba yung X bar natin? 85. 85. So 85 to. So we got here 559.836 newtons, and that is directed downward. Okay, so let me store it sa bagong E. Okay, so yun na. So solve natin yung due to eccentric load. What would be RC? Okay, that would be square root of summation of X 262 263 4511 square plus summation of forces vertical. We have yung RD natin is 160, diba? 160. Pataas yung RD natin na 160, pero yung RTY component natin pababa. So minus 559.8336, then quantity square. So that would be the resulting shear force for RC. Okay. So that would be square root of 160 minus alpha E square plus alpha D square. So we got 478.8251 Newton per millimeter. Okay? Question about this one?
None, sir.
And the unit, the direction would be up, downward to the right. So with this, so we have solved for the shear forces on C and B. And ang RB is 708, and yung RC naman is 478. So of course, our maximum, so therefore, okay, Rn max is equal to Rb, which is 708.544 Newton per millimeter length of weld. Okay? So, kung alam mo na yung shear force, how do we design? So, yung tanong is design. So, what would be the design W or size of weld? Okay. Diba, sabi natin, the design strength should be greater than or equal to the ultimate. Okay, since the given load in the connection is already factored, P sub U na yung given, it follows that yung RB na na-solve natin na to is already R sub U. Okay, ito na yung pinaka-ultimate. Ito, so ito na yung pinaka-RU natin. Okay, so ano yung phi? Phi is 0.75 for connection. Ano yung Rn natin? Ano yung Rn natin? Diba yun yung shear strength, Fnw, times the area of the shear for weld should be greater than or equal to Ru. Okay. So 0.75. Okay, ano yung FNW? Ano yung shear strength ng weld? Diba? As per code provision, that is 0.6 of the tensile strength. The tensile strength is yung FEXX. Okay? Tapos yung AV, ano yung AV? Ano yung area for shear pagka-weld? Yung dinerive natin na formula. Diba? Yung area of the shear is equal to the throat distance T times the length L. Ayan. Greater than or equal to RU. Okay, so we have 0.75. Okay, so that would be 0.6 again of the tensile strength. Okay, ano yung throat distance in terms of the size? Diba that is sine 45 degrees times W. And sine 45 is 0.707 and W is the size of weld. Yan yung throat distance. Times the length L. Should be greater than or equal to R sub U. Ayan. So direct substitution na tayo ngayon. So direct substituting the values, so we'll have 0.75 times 0.6. Ano yung electrode na ginamit? Diba electrode 60 sabi sa problem? So 60 KSI. Convert natin sa megapascal, 6.9. So megapascal na yan. Times 0.707 times W is yun yung tinatanong. Tapos yung length natin is unit length. So 1 mm. Should be greater than or equal to RU. RU is 700. 8.544 newtons. So consistent naman yung units, no? Kasi this is megapascal. Megapascal is newton per mm square. Tapos ito namang area natin is mm square. Tapos yung load natin is in newton. So solving for that W, it should be greater than or equal to divided by 0.75. Okay, the size of weld na lumabas here is 5.379 millimeters. So, yan yung pinaka-size ng weld needed for our connection. Okay, so of course, our welds are usually rounded up to whole numbers, say 6 mm pwede. So that would be the size of the weld needed for the design of this connection. Then you just have to check na lang yung size na kinalculate natin na to based from the table of W min, minimum, and the W maximum as per code provision. Kailangan yung kinalculate nating W, yung 5.6 say 5.3 say 6 mm, yung calculated design size of weld of 6 mm should be in compliance with the W minimum and the W maximum. Okay, so that is how we design eccentrically loaded welded connection.